Thanks for coming. It's dinner hour, so I really appreciate everybody turning out like this. My name is Rich Gavuge, and I'm an Esri developer with the DC R&D Center. And I'm going to be talking about a software product called Koop. And I work on this about half of my time. I work the other half of the time on the Hub API. I get to work half-time on this, and I'm really happy to talk to you about it today. Is anybody familiar with Koop? Show of hands. Okay, yeah. Well, great. Just to kind of lay out what I'm going to talk about, I'm going to go over what Koop actually is, and talk about request lifecycle and Koop plugins, and then something new called the Koop CLI. And then finish up with a walkthrough on building what's called a Koop provider, which is a Koop plugin type. Okay, so first question is, what is it? And the simplest way I describe it is it's a web server that performs on-the-fly transformations of geospatial data. You can sort of think of it like a ETL, except it doesn't physically move anything from one place to another and permanently transform it. It leaves data in place in the format that it's found in, and then it delivers it on request to a different format. So you can just leave your data where it lives, and you can get it in whatever format you want. Koop is completely open source. It's free to use and free to contribute. It's written in JavaScript and runs in the Node.js runtime. It's built off of the Express web server framework. So if you have worked with Express, you'll be really familiar with what you see once you start looking under the hood. All of the components are published with NPM, so it's easy to install, and it's gotten easier recently. I'm excited to show that. It's got a plugin architecture, and the nice thing about that is it allows you to customize your Koop instance easily and just for your specific needs. You don't have to install a lot of things that you're never going to use. Probably the most important part about it is that it supports the GeoServices API spec. And that's just another name for the ArcGIS Feature Server API. And that is what allows Koop to connect data from a lot of different sources to ArcGIS clients. Koop understands requests that are written in Feature Server API, and it can respond to them. The big question that I get is why the name Koop, and there's nothing geospatial about it. I didn't name it. A guy named Chris Helm, who originally started the project, I assume was a big fan, and it's stuck thus far. So that's all there's really to say about that. But conceptual overview. There's this web server, and then we've got these kind of two different main types of what we call plugins. They're Koop providers and Koop output plugins. And a provider is just, it's really a data adapter for things like this, Elasticsearch or MongoDB or AWS S3. So the providers reach out to these other APIs and pull in data, and then shove it off to these output plugins. And the output plugins are things like this. So as I mentioned, the GeoServices, maybe vector tiles or web mapping service or WFS. So the data is coming from these remote APIs, and it's getting transformed into these outputs. And as I noted, because of the GeoServices API plugin in particular, we can load up this data into these ArcGIS clients. All of these clients know how to work with ArcGIS Feature Server API, and as a result, they can work with Koop. Let's see. So when would you want to use Koop? Well, as I noted, you might want to use it if you want your data in ArcGIS clients, but that data isn't supported directly by those clients. So your data might be tied to an existing format because of existing business application, or it might be you might want to use data from a third party that you can't control at all. Maybe you have a data store that's not supported by SDE, so you need to figure out something else. You also might want data delivered in a lot of different formats, and with Koop, the existing output plugins, or you could write your own additional new output plugin, you would be able to support that format in addition to everything that Koop already gives you out of the box. Okay, so probably best to just do a quick demo here. I'm going to show a web map from ArcGIS Online. And that web map is going to reach out and pull in data from Craigslist, from GitHub, and from AWS 3. So hopefully the demo gods will be kind to me. And here it is loaded up. I'm going to just, refresh that. Yay, it's working. Okay, so we've got breweries here, and that's living on a pipe delimited file in S3. We've got Craigslist apartments, which are the gray dots. That's just coming live from Craigslist. And we've got GeoJSON, some contextual layers, Seattle parks, and Seattle neighborhoods there. So you can kind of see how you could do some analysis with data that you might not normally be able to get into ArcGIS Online very easily. And I just want to show a couple of things here that you can do. Let's see if I can get. I'm coming at this from a weird angle, so give me a second. So for example, since Koop is able to understand ArcGIS feature server API, we can leverage things like filtering. There we go. We can leverage things like filtering. So for instance, say that we wanted to only look for apartment listings that had a price less than $1,500. And we're able to filter down points. You can also open up the attribute table and see the Craigslist data. You can do an identify and a zoom to, and so on and so forth. Again, all that's because ArcGIS Online is using Feature Server API to make requests, and it's sending those to Koop instead of ArcServer in this case, or a hosted service. Let me switch back to this. There we go. Okay, so let me talk about requests a little bit in Koop. Using the example of Craigslist, this would be a typical feature server request, query request. And the colorized fragments are the route parameters. Koop just sees this really more like this, where those are the route parameters. They're variables. They can change on each request. But sort of the more important thing that I want to point out, at least for now, is these sort of two families of request fragments. The first side is what we call the provider fragment, or what I call the provider fragment. And then the second side is the output fragment. And these two things link a provider and an output together so that Koop kind of knows how to pair provider plugins and output plugins on request. So this is still a bit of a conceptual overview, but it's a little less conceptual. So when what happens is a client makes a request to Koop using that request form that I just showed. And the Koop servers knows which output plugin to send it to. The output plugin then asks the provider to get data, and the provider reaches out to the remote API. The remote API sends back the data, and while it's in the provider's responsibility is to turn that into GeoJSON. GeoJSON is the common tongue of Koop. So all providers have to turn whatever format the data that comes back from that remote API into GeoJSON. And then the GeoJSON is passed back to the output plugin. And the output plugin in turn may do a couple of things. It's obviously going to turn GeoJSON into whatever output format the output plugin is responsible for. So in this case, if it's a feature server or GeoServices API output plugin, then it's going to return Esri JSON. Output plugins can do more than that too. It can often do some post-processing operations like filtering or sorting before sending on to the client. Now, that was a pretty simple instance of Koop that I showed. You can use something called a cache plugin to increase performance and get around things like rate limiting on your remote API. So if you install the cache plugin in Koop, when you make that initial request, instead of going straight to the provider, what happens is it checks this cache to see if the data you're asking for has already been requested before and is waiting. The cache might be an in-memory cache, or it might be something more durable like Postgres. But in any case, it checks the cache, and if it's not there, then it just proceeds to the provider, where it sort of does the same thing that we just saw. It gets the data from the remote API and is about to send it back to the output plugin. But before doing so, it sticks it in the cache. And it uses the request as a key for that cache. So the next time you make that same request, it goes to the cache and it's able to find it. And it circumvents going to the remote API. So this is really useful in terms of bigger data. So it will increase performance. You have to make that further trip to the remote API. It's also good for a rate limiting situation where you might want to not keep hitting that remote API because you'll run up against some threshold where you'll be blocked out. There's a fourth type of plugin that I wanted to mention. Up until this past year, if you deployed a Koop instance, you were essentially making all your services completely open. There was no way to secure those layers. And that's changed now with the Authorization Plugin. If you install the Authorization Plugin, you can lock down provider services. You don't have to necessarily do authorization a certain way. The Authorization Plugin just has a spec that you have to conform to, some certain functions that have to be there in your Authorization Plugin. So let's say that you want to just do simple token validation. You can do that. You just have to wrap it in the functions that the Koop server expects the auth plugin to have. The nice thing about this too is that you can, if you have multiple providers in your Koop instance, you can lock down some of them. You don't have to lock down all of them. You can be selective. So you might have some data that you want to remain public, but other data that you want to remain private. Okay, so this is part of Koop that I'm really excited about. It's called the Koop CLI. It's a command line interface for doing some tasks in Koop that have, up until now, taken up more time than we'd like. And I really want to thank my colleague, Haoyang Yu, for putting this together. This is sort of his idea, and he's really made the big push to make this happen. And what you can do with the Koop CLI is you can generate a boilerplate for a Koop instance with just a single command. This used to take, a lot of, maybe using templates and doing your own typing setup and just some tedious tasks now that have been automated. You can also use it to install plugins into a Koop instance. It's got commands for serve and test. And you can also use it to generate boilerplate for a new Koop provider. So if you're starting development on a new Koop provider, this gets you rolling really quickly. And so I want to do just a quick demo of the Koop CLI. And it's over here on my other screen. There we go. How's the text size on that? Okay, good. Okay, so the Koop CLI is it's a global NPM module. So once you install it, you can just get it at the command line. And if I do that, then I get the help screen. So it'll give you a quick overview of what you can do. And what I'm going to do now is I'm going to use it to generate a new Koop instance. So if I go Koop, add app, and I just give it a name, Koop demo. What did I do wrong? Yes. Right, because I'm not adding plugin. Thank you. There we go. So it's creating the file structure and it's turning it into a Git repo and adding the templates that it needs. And right now it's paused because it's doing an npm install, so it's installing all the node modules. And if I do a tree on this, you'll see the file structure. And so you're good to go. And then the next thing you do, if you were just quickly setting up a Koop instance, you'd cd into Koop demo. And then you do a Koop. Now I want, say it again? Oh, thanks. Really hard typing and looking sideways. Koop demo. Thank you. Okay, so now I want to do Koop add, and then provider, and then the last argument is simply the npm name. So I'll add the GitHub provider. No, that's not it. Didn't work. Looks like it's working. Excellent. And so finally, if I do Koop serve now, there it is. So this is just the console output showing you that it's listening for these routes. And I think I'll tempt fate and see if we can get some data out of it. Oof, that's terribly large. Tell you what, I'm going to curl it. There we go. I've already got it set up. So this is just hitting that localhost instance of Koop. I've got the route set up for the GitHub provider. And there it is. So that is Esri JSON for some GeoJSON stored on GitHub. I got that live. I don't have the cache set up for that demo that I just did. Yeah. Let's see if I can get back here. Excellent. Okay. So now I'll jump into building a provider. So again, a provider is just a data adapter for a remote API. And you can kind of boil down building a provider to 4 steps. You need to construct the remote URL and make the request to the API. Once you get the data back from that API, you got to translate it to GeoJSON and then decorate it with metadata. And then you fire a callback and with the GeoJSON as an argument. And of course, you'd want to handle any errors in that. So proceeding with those 4 tasks that we have to do, there's a little bit of grunt work. The first is doing a little research. So for the example here, I'm going to use Socrata. Socrata has a API that you can go to the Socrata developers page and learn all about it. But right here on the developer page, we can see the URL that they use to do a query for their data. And you can kind of break their URL down much the same way we did with the Koop URL. They have a host fragment and an ID fragment. And then everything else on the end there is a query string with filters. So looking at that, you want to keep in mind what your Koop URL is going to be, because you're going to have to transform your Koop URL to your Socrata URL in your provider. So this is actually almost a one-for-one here, where we've got host and ID in the Koop URL, and we'll be able to use those to pass in the Socrata parameters that we need. The other thing to think about when you're kind of researching your remote API is the response format. So in this case, Socrata is just sending back a JSON array. It has a number of properties in there, including the one that I want to point out is the location _1, which is the geometry for the record. And that looks like a GeoJSON point geometry to me. So that's going to make things a lot easier. The next thing you want to do is I would use Koop CLI to generate the boilerplate for the provider. And I won't do this one live, but it's basically very similar to creating a new app. It's Koop new provider. You give it a name that you want. Goes through the process of spinning everything up. And once it's done, you get this nice file structure. Then the most important files in here for development are in the source. This index and model. Index is really used by Koop server to register the provider. You will go in there to set up which route parameters you want to use for the provider, and not much else actually. Depends. If you get into kind of deeper provider development, there are some things in there that you can turn on and turn off, but for the most part, you're going to be working in Model.js to do the 4 things that I spoke of earlier. So this I'm a little bit worried about. Can people in the back see this? Not really? Yeah. So this is what you'll see when you get into Model.js. There is a class called model, and there is a prototype function called getData. It is the only function you need to have on model, because this is the function that Koop uses. This is the function that Koop calls when the output plugin needs data. So you absolutely need getData, and it needs to do the things that we talked about earlier. So constructing a remote API. Here that's really simple. It's just taking the route parameters from the request object. If you've ever worked with Express, the request object will be really familiar to you. There's a property in there called parameters, and you can get your route parameters from there. So I've simply taken the route parameters that are coming in from feature service URL and reconfiguring those to make the Socrata URL. The next thing you'll want to do is you just fetch the data, and you can use whatever library you want to do your fetch. Here I'm using node fetch, but you might want to use request or request promise. Just make sure that you turn it into JSON when it arrives, and then you're on to translate. Okay, so the translate function tends to be where a lot of the development work gets done. Here you're basically going for this. The left side is what Socrata is sending us, and we're trying to get to the right side, which is feature collection, GeoJSON feature collection. Again, this is actually not that bad of a translate to have to do because it's pretty straightforward. So this is just a translate function, and all I'm doing here is I'm pulling the JSON in and I'm remapping it. I go through each record and I create a feature object and then create all the things that you need for a GeoJSON feature, right? You need a type, you need properties, you need a geometry. So I set the type to feature, and then I just copy all the properties of the record over to the feature properties, with the exception of the location, because that's going to become our geometry. At the end, once I've remapped all those features, I just wrap it in a feature collection object, and I'm done. Okay, so then I talked about adding metadata to that feature collection. Metadata is important to some of the output plugins. The only metadata that's absolutely mandatory is this geometry type. You'll need to set that. If you don't, and you make a request to the feature server endpoint, you're still get back data, but you're gonna be told that it's a table instead of a feature layer. And that's one of the most common questions I get is, oh, my data's not rendering, and it's because it's coming back and being tagged as a table. And so the ArcGIS clients won't render it. So remember to set that geometry type, and you won't have that issue. There are a lot of other metadata that you can set here, though, that become important. If you go to the Koop documentation page, you'll see a whole list of different metadata that you can set here in the provider. Name, description, display field. These are things that if you set them, the data coming back to the clients will respect what you set. So if you want display field to be something in particular and not just the default, you can set it in metadata. We have plans to expand this. This isn't exhaustive. I know, and I think some of them may or may not do what we totally expect right now. I think time info, for instance, needs contributions. So we'll be addressing some of that in the coming year. Okay, the last thing you want to do here is you just fire the callback. Just pass in the GeoJSON. You want null as the first argument because that's the error object. And then, of course, you want to catch any errors. And so what happens after the callback is that GeoJSON is handed back to the output plugin, where the output plugin does its work. Might post-process it, might filter it, might sort it. Depends on the query parameters that came in on the request. And so this code here that I have, I've got the repo ready to roll. And I'm going to run it. And with any luck, we'll be able to see it in action. Oh, sad. Oh, that's actually an easy fix as I go. I forgot to shut my other demo server off. Just need my mouse to come back. Say it again. Oh, thank you. Command 1. Oops, not that. Come on. There we go. Okay. 3. Let's try that again. Yes. Okay, great. And I've got Postman set up here, so I don't have a good mouse. Oh, it's because I ngrokked it. Try that. I think it's going to port block me. Yeah, it did. So we'll have to settle for Postman and localhost. I wanted to do this as a web map layer, but ArcGIS Online won't let me. There we go. ArcGIS Online won't let me, of course, load a localhost layer. So sorry about that, but can't do much about the port being blocked. There we go. Make it smaller. Okay, so over here you can see this is actually the layer query, the layer request. But if I add query on here, I'll actually get the data back. There's the features. The other thing that I want to show here is it's the same request, but I've added a where parameter on here to filter the data. So if I send that, it's not what I'm expecting. Try it on here. Should be good. See, oh, there we go. Not sure why that took so long. It should have been pretty quick. I've got a reduce set here that obey these filters that I've added. So the filtering in this case is happening in the output plugin. So it's a little less efficient than we might like because we're going to Socrata, we're getting all the data, we're bringing it back to the output plugin, and then we're applying the filters. So that sort of gets to this point of like, what is the it gets to the point of, sorry about that, it gets to the point of that we have two different types of providers. And so two different types of providers, we can kind of be classified as cached or pass-through. So a cached provider is kind of what I just put together, where you get all the data at once, and then you do any kind of post-processing you want in output plugins. And you can do that when the data is small or maybe when it doesn't change very often. Alternatively, you can build something called a pass-through provider. And in a pass-through, you are getting a subset of the data by passing the filters from your request back to that remote API. And you want to do that when the data is large, but you really can only do it if the API you're talking to supports those filters. So if your API doesn't support filters, you're kind of stuck with the cache provider. And so let me just show an example of how I would go about doing that. So this code is a little bit different. I still start out with this base URL for the Socrata API, but then I take that request, the request where parameter coming from the query string, and I turn that into a set of filters that I can apply to the Socrata URL. I didn't want to go into a lot of detail about how to do that because basically what you're doing is you're parsing a where clause from Feature Server API. And the where clause can be quite complicated. So it can get sticky really quickly. Particularly because the Socrata API doesn't support things like the OR operator or the like operator. So a request might come in like that, but you can't support it necessarily in Socrata. So what you sort of have to do is you have to be careful about traversing the parse tree of the where clause and pulling out what you can to pass back to the Socrata API. So that's essentially what I do, and then you just want to flatten it into a query string once you get it and add it onto that URL. So we did try it out. So, that's right. I can't do it in ArcGIS Online. So my try it out isn't as fun and dramatic as I was hoping for. Okay. So, in terms of what's coming for Koop, we're going to continue on with more provider development. We've had a couple of interesting providers come out recently. Most recently is AWS S3 Select. So you can have files on S3, and if they're a certain type of CSV or JSON, you can use a subset of SQL to request that data. So we've started to build a provider that uses S3 Select to pull in data to Koop. And that's what I was using in the demo earlier for the S3 layer, the breweries layer. We're going to be expanding support for Elasticsearch in the Elasticsearch provider, and also going to begin work on another AWS provider plugin, but this one using Athena. Athena is a great fit for Koop because its SQL it supports more SQL operators than S3 Select. So we can do a lot more, and you can query geometry. So if you want to build a pass-through provider for Athena, it sort of provides the raw materials to do that. In terms of output plugin development, we're going to be creating an output plugin for protocol buffers, potentially revamping some of the vector tile output, and continuing to develop on the WMS and WFS. We're hoping to support quantization in the GeoServices output plugin. And we're going to keep moving forward with the Koop CLI, probably some more development templates. And we want to make deploying easier. So we'll probably add the ability to deploy to something like Claudia or the Now Cloud service. And as always, trying to improve the documentation. We did do a reboot of the documentation a few months back, but we just need to keep adding to the content now. So I would encourage you to contribute if you can, if you're interested. And just some resources for Koop. Visit our GitHub organization. It's a long list of all the providers that we maintain. There's the Koop documentation page, and you can get a much more detailed provider specification there. It talks about a lot of things I did today, but in greater detail. Also check out the Koop CLI if you're already a Koop user. I think you'll like it. And I'll have the demo code for what I showed here on my own GitHub page. And so with that, I'm happy to entertain questions. Thanks.
Can you talk through what you do in a situation where the other API that you're talking to doesn't give you the data in exactly the right spatial format that you would need? So for example, if they just give you an address and you have to geocode it, or if they give you a polygon and you want to get the centroid.
Yeah, I mean that's an excellent point. That translate function I showed was really simple, right? You didn't really have to do much except housekeeping. So in that case, you just start building out the provider to do what you need to do to get it into GeoJSON. So for instance, let's say that you were in a different projection, right? You need to get it to WGS 84. And so in that situation, I'd pull in other libraries, or I'd have to actually write the code myself to do what I needed to get it to GeoJSON. Yeah. Yeah.
So I was curious, have you had output feature service? Have you had any trouble putting in insights for ArcGIS?
So I started at Esri about a year ago, and then my first task was to get Koop working with as many different clients as I could. So about a year ago, there were substantial issues with getting Koop feature services in some of the clients. Pro, ArcGIS Online. We've addressed, I think, the majority of those. I haven't had any trouble using it in Pro or ArcGIS Online, Scene Viewer, or ArcGIS Earth since the improvements we made last year. I've tried it on Insights recently because somebody submitted an issue, but I could not replicate. So I won't attest to Insights yet, but I haven't been able to replicate, and they haven't gotten back to me, so. Yeah.
What about WebSockets? So like something can push data to Koop remotely.
That is a really cool idea, and it's one that we've kind of been talking about a little bit. I think it will take some special modifications just because of that. The way that Koop works right now, it's very much HTTP, and passing, hitting certain routes, providers. So I think in the short term, if you wanted to do something like that, you can do custom routes on the provider itself. And so I think you could add WebSocket communication to the provider itself and possibly bypass the output plugin to do what you needed to do. I'm not completely sure. We haven't tried it.
Thanks.
Yeah. Yeah.
Do you have any vision to support the feature service API for like applying edits and that kind of thing? So coming back the other way?
Yeah, we've been asked about that, and that is something we definitely want to do. Right now, you can potentially do it on a per provider basis by doing custom routes and custom controllers. But I like the idea of supporting that in the future. It's definitely something that we're in discussions about. Definitely looking for contributions too. So, any others? Yeah.
How much does Esri use this internally?
That's a good question. We actually use it in open data. It's part of our Downloads API. It's a big part of the Downloads API. It's sort of a foundational component of it.
Is this how you're doing the OpenStreetMap basically?
I don't think so, no. But it's how we convert, it's used in converting feature service data or ArcGIS Online data to the download files that you click on and receive. Any others?
So the provider can be configured to perform join operations?
Possibly. It's not something that I've done before. But I think you could do it, I guess.
What was the question?
Oh, sorry. It was, can the provider be configured to do join operations? I haven't seen it done, to be honest. But I don't see why you couldn't potentially do that. I guess you would maybe do separate requests to different data, and then you would have to do the join on the fly. That's the first thing that comes to mind. It's a more complicated provider for sure. Yeah, and we don't have anything out of the box that aids that yet. But, I would really recommend, if people have ideas, please submit issues to our Koop GitHub. We'll tag it with enhancements, and that's how things make it onto our roadmap. So we're excited to provide more, and we're just looking for input on what people really need.
I think you could connect to SQL Server using the SQL Server client for Navigate.
That's a good question. Quite possibly. I didn't realize there was a SQL Server client for Node.js, but if there is, then it certainly seems possible. I know that there's a PostGIS provider. So probably just generally work the same way that one does. Yeah. Well, thanks very much. Enjoy the party.